Hello, I'm Neil Polhemus, Director of Statgraphics Development at StatPoint Technologies. It's my pleasure to be the first to introduce to you Statgraphics Centurion version 17. Version 17 is the latest version of StatPoint Technologies Windows-based software for statistical analysis and data visualization. It's the 17th version of the product we've produced for PCs, the first version being released in 1983. Version 17 is a major upgrade, featuring 32 new statistical procedures and significant changes to 20 existing procedures. The new procedures include 19 dynamic statlets, where users interact with the analysis by changing options on a toolbar, and they see the effect of those changes instantly on the graph. Version 17 also features increased data capacity and other user interface additions, such as a session log, an audit trail, improved graphics editing, and passwords that may be assigned to StatFolios. An area in which Statgraphics has always excelled is that of data visualization. Version 17 adds many new capabilities. Some of these include dynamic bubble charts for displaying multivariate time series, a multivariate visualizer where you can choose either a bar chart, a profile plot, a strip plot, or some other glyph. New demographic maps, which use gradient fills to display the value of a selected variable. A correlation plot, also called a Corrgram, which uses colors to display the values of a correlation matrix. Geospatial data maps based on Kriging, and a bivariate density statlet that displays the joint density of two variables. Here's a quick illustration of how the dynamic visualizer statlets work. This is the 2D visualizer showing some demographic data for all 188 countries in the World Bank's dataset. On the y-axis, you see the life expectancy of a particular country. On the x-axis, you see the fertility rate, which is the average number of children that a woman has. The points are color-coded according to the infant mortality rate, and initially the data are displayed for 1961. I can use this slider on the Statlet toolbar to change the year. In this data, the year ranges from 1961 through 2009. I can also let the year change automatically, and you'll see a general tendency of the world to move toward higher life expectancies, lower fertility rates, and lower infant mortality, as you'll see most of the red disappear as time evolves. There are a few options available on the visualizer statlets. One option is the ability to add breadcrumbs. If I ask for analysis options and say I want breadcrumbs for all of the points, okay, what it will do is it will leave behind a trail as time evolves. This way you can see the path that individual countries have followed. And you can see that there are a couple countries who made some fairly interesting paths, although at the end everyone seems to have joined the general trend of the world toward the upper left-hand corner. If there are particular countries I want to highlight, I can also do that. Let's bring it back to 1961, push the Analysis Options button, and ask for a label to be placed on Yemen. It's now put a little YEM above the bubble for Yemen, and you'll see when I let time run now quite an interesting track for Yemen. Initially, the fertility rate went up. In fact, it went up to over 9 children per woman. Then around 1985 turned and followed the rest of the world toward lower fertility rates. These interactive statlets show you a lot that you can't see in a static display. The Multivariate Visualizer uses other types of graphs to show the values of multivariate time series. Here you see crime rates in 1978 in each of the 50 states and the District of Columbia. Again, users may use the controls on the Statlet toolbar to see the plots change with changing year. The demographic maps now display any area defined by a BNA boundary file. In the visualization Statlet, a variable is selected to color each region, and changes may be seen as time evolves. The correlation plot, or Corrgram, displays a correlation matrix by coloring each cell according to the magnitude of the correlation. Variables are positioned according to the first principal component, which places similar variables close to each other. Here's a map created by the Kriging Statlet. Kriging is used to estimate the distribution of a variable based upon data collected at different locations throughout a physical area. Finally, here's an estimated bivariate density using a non-parametric lowest smooth. It estimates the joint distribution of two variables. Users can change the smoothing parameter and instantly watch the estimates change. Another area of Statgraphics where significant enhancements have been made is that of quality management. We've added acceptance sampling plans based upon various military standards. We've added G-charts and T-charts for monitoring rare events. We've added Laney U' and P' control charts for over-dispersed counts and proportions. The statistical tolerance limits procedure now computes two-sided limits and one-sided bounds for 12 different probability distributions. We've improved the process mapping and cause and effect diagrams. We've added reliability demonstration test plans for life data. We've also included a deviation dashboard for monitoring multiple variables. The new acceptance sampling plans implement various military standards for accepting lots based upon attributes and variables. The user specifies the lot size, the verification level, and the type of inspection. Statgraphics then determines the number of items that need to be inspected and the acceptance number and rejection number of the plan. The reliability demonstration test plans are used to show that a failure time distribution satisfies stated requirements. Given a requirement on the reliability of a process, the procedure determines the number of items that need to be tested, the required duration of the test, and the maximum number of failures that would be allowed. The deviation dashboard is used to monitor multiple variables. At a given point in time, it shows with a bar how many standard deviations each variable is from its mean. Bars are colored green, yellow, or red depending upon the position of the bar with respect to the three sigma limits. The Statlet controls on the toolbar may be used to change the year at which the data are displayed. Another area where version 17 adds significant capabilities is the design of experiments. New computer-generated designs are available based on A, D, G, or I optimality. The user specifies the model to be fit, the number of runs that can be performed, and any constraints that might exist on the factors. The program then generates a set of optimal runs. We've also added new three-level fractional factorial designs to the screening section and two new procedures for analyzing repeated measures experiment. This is the main dialog box used to create a computer-generated design. In the bottom left corner, the choice is made between I optimality, D optimality, A optimality, or G optimality. In the bottom center, the user specifies the number of base runs to be generated, the number of replicates desired, and the number of center points, if any. When the Create button is pressed, the computer generates an optimal set of runs to be performed. Repeated measurement experiments are experiments where multiple measurements are made on the same experimental subject, often at different points in time. The new procedures in version 17 automatically estimate the proper error sums of squares for the within subject factors and the between subject factors. It also runs tests of sphericity and applies sphericity corrections if measurements made on the same experimental subject are not independent. In addition to new statistical capabilities, enhancements have been made in version 17 to the Statgraphics user interface. One of the most significant enhancements is the addition of a session log. The stat log keeps track of all output generated during a session. Another enhancement is the ability to add passwords and audit trails to a StatFolio to keep track of who and when a StatFolio has been changed. Rather than linking to an external data file, StatFolios may now store the data internally if the user desires. New graphics editing capabilities have been added to all graphs in the program, and a new Tabular Options dialog box now allows changes to be applied to a single output table. The stat log is a separate window in version 17 that keeps track of all output generated during the session. It may be saved at the end of the session as an RTF file and imported into Word if desired. Here's a graph that highlights two of the new graphics editing features. The first is the ability to click on a single object, a single point, a single line, a single bar in a bar chart, and change the features of just that object. The second is the ability to add new objects to a graph. Objects such as an arrow or a rectangle or an ellipse or even a new function. The Tabular Options dialog box lets you make changes to a single text pane. You can change the width of the output. You can change the p-value used by the stat advisor to interpret the output. You can also change the number of significant digits used by the table to display statistical output. If the table has row numbers, such as a table of residuals, you can use a label rather than the row number to identify the rows. Finally, if you deal with regulatory authorities, you can now apply passwords to a StatFolio. A password would restrict a user from making changes except those that you authorize. Together with the ability to save data in the StatFolio and to track a StatFolio with an audit trail, you can demonstrate to the authorities that a project StatFolio has not been changed. I hope this video has given you a sense of the many capabilities we've added to version 17 of Statgraphics Centurion. There's a lot I didn't talk about, but you'll see it all if you download and install our 30-day trial. You'll find a lot of capability there to make your data analysis more productive.